Hello, I'm Gustavo and I'm going to present the paper intitulated Criteria and Guidelines to Improve Software Maintainability in Software Product Lines. The authors are me, Ramon Abilio, André Freire, and Heitor Costa. Software product lines is an approach to design and implement software whose purpose is to promote systematic and large-scale reuse of features. Once the software is decomposed into features, we can have different versions by recombining features. To implement feature-oriented GSPLs, you can use composition and annotation-based technology. For example, a head and composition-based technology holds artifacts that compose common core of ESPLs are treated as constants, and the other artifacts can be called refinement functions. An industry goal is to develop software with high quality and minimum number of errors, defects, and faults. However, quality is a subjective concept. A software with high quality for a developer can be low quality for a user. Therefore, measures must be used to ensure software quality. Maintenance in ESPL should be more complex than in systems not designed as ESPLs, because changes in a model can affect their products. It deserves attention from the academia to provide techniques to help developing more maintainable ESPLs. The number of tools and guidelines to help maintaining or increasing ESPL maintainability is limited. This indicates the existence of an open field to research related to ESPL's maintainability. In this paper, criteria and guidelines are described to increase the maintainability of ESPL. The main goal is to evaluate the impact of maintenance of the source code of the features that compose an ESPL when criteria and guidelines are followed. Guidelines show alternative ways to solve identified problems. The first methodology procedure used was a literature research to identify candidate ESPLs developed in years ahead. We chose Tankiwar ESPL because it was reported in other study as better explained later. A detailed analysis of the source code was performed for better understanding this ESPL. After, we studied code standards, structural problems of source code, and refactoring methods. Legibility and complexity problems were pointed out and ways to solve them were described. Next, we decided to use Maintainability Index due to its wide use in the industry and academia, included in the context of GSPL. MI's goal is to measure quantitatively the system maintainability and to help reduce maintenance costs. To calculate MI, some metrics are used, such as Halstead metric and McCabe cyclomatic complexity. The fourth step was to determine which products generated from the SPL would be analyzed and modified and use the proposed guidelines. We used a product that involved all ESPL features. The SPL has two platforms, PC and hand. It is something like mobile in German. This means that one product can run only in one platform. It is not possible to use all features in the same product. Therefore, we decided to choose 3 products with minimal, intermediate, and maximum number of features for each platform, resulting in 6 products in the total. Subsequently, guidelines were used in 2 phases. In the first one, the legacy ESPL was replicated in 7 different projects, and in each replication, each problem identification criteria was evaluated and respective guidelines related to the criteria were used. In the second one, the criteria were evaluated and guidelines were followed cumulatively for the same ESPL. After MI was calculated and analyzed, comparisons and discussions were done. We performed quantitative analysis of the differences in MI of the products before and after using guidelines. We used related sample signal rank Wilcoxon tests to verify whether there were significant differences in MI using a 5% significance level. 7 criteria was defined. Each criterion has description, motivation, and 1 or more guidelines. Definition of criteria, identify maintainability problems, and elaboration of guidelines for improving them are needed to guide software engineers and developers to perform maintenance and increase the ESPL maintainability. This criteria has been applied in developing or maintenance of ESPL. These are the 7 criteria. The first and the fourth are to know if some mechanisms are explicit. The second and fifth are related on the responsibility of the method and classes respectively. The third one is related to code clone. The sixth is related to data encapsulation, and the seventh is related to code standards. Thank You Are ESPL is a game developed by students at German University of Magdeburg. It is an ESPL of approximately 5,000 lines of code and composed of 37 features. Thank You Are ESPL offers possibility of generating around 40,000 different products, but we chose 6 products for analysis. We believe that these products can express a representative set of functionalities of Thank You Are ESPL because all features are used. In spite of Thank You Are ESPL having 31 concrete features, product with maximum number of features has 23, and product with minimal number has 6 features. The products have the MEI around 77 and 82. For example, the MEI of product 6 is 78.41. Let's go to the application of criteria. First phase, apply it separately. This table presents the MEI of each product after using the guidelines. This table presents the MEI variation after using guidelines comparing the MEI of the products from the legacy Thank You Are ESPL. 3 types of results were obtained: positive when MEI increased, neutral when MEI remained the same, and negative when MEI decreased. We will perform a set Wilcoxon test to verify whether there was significant difference between MEI of the products after applying each criterion. No significant difference was found only after applying criterion 4. In spite of negative results obtained after applying guidelines related to 4 criteria, we believe that some alterations have beneficial effects not protected at MEI. For example, following the Java code conventions, we introduce new lines to source code because it states that declaration of variables need be one for each line. In other cases, we believe that these results happen for products and not to ESPL as a whole. Thus, the number of lines can be larger for one product, but can be smaller for the ESPL. As a result of the first phase, we can observe how to determine an order wherein the criteria could be applied to make the maintenance process more efficient and reduce rework. It is better when eligibility criteria are applied first on the complex criteria. The optimized order is better explained on the paper. This order was used to the second phase. Application of criteria. Second phase, cumulatively. MEI after performing each step is shown in the table. This table shows the variation on MEI of each product comparing MEI after applying one criterion and the previous MEI of the product immediately before its application in a cumulative fashion. This table presents difference between increments obtained by applying the criteria cumulatively and separately. Cumulative minus separate. We perform analysis to verify if there was significant difference between applying each criterion separately and applying the criteria in the proposed order. With Wilcoxon tests, we can see that we have significant differences to criteria 1, 3, 5, and 6. No significant differences were found for criteria 2, 4, and 7. When comparing MEI of new and legacy Thank You Are ESPL, increase of the maintainability is notable. The average MEI variation was 13.82 points. We can observe that the results were positive in all products, especially by the perception of deficiency of documentation of legacy Thank You Are ESPL. We need to highlight that many decisions were taken to find the results of this work. First, we choose a metric to assess the maintainability. The MI was chosen because we found another work that used this metric and present a good way to calculate the ESPL maintainability. However, we assume that this could not be the most adequate metric. It is possible that we will have some error calculated the MI and Wilcox tests. To try minimize it, two researchers computed the metric and calculate MI in different computers. If some anomaly was found, all process of measure or statistical analysis should be started again. The gap of a tool to measure the maintainability of head ESPLs did that we choose some products. In general, enterprises maintenance have a reduced number of products, but the maintainability should be measured from the SPL or from the SPL features. We believe that we choose products that represent a clear SPL, but it is difficult to affirm it. The criteria were defined only with the problems detected in the SPL studied, although trade generic problems. We can say that some of these criteria are going to be found in other SPLs, but the result can be different from ours. The result was positive use guidelines not only considering the increase of MI, because some shortcomings of legacy tankware ESPL were reminded, such as lack of documentation comments. When considering criteria 1, an analysis of the quality of comments should be performed because software with many characters or lines of comments does not necessarily make it easier to understand. We conclude that products MI does not vary directly and proportionally with MI by the tankware ESPL. Furthermore, performing maintenance on ESPL is not as trivial as changing single systems, because changing in several models can generate side effects in many products, and tests should occur in several products and not in only one. The main contribution of this work corresponds to definition, testing, and evaluation of a set of criteria and guidelines. Another was suggested to avoid rework and make the maintenance process more efficient. As limitations, we did not find any tool to ensure the ESPL maintainability or able to calculate some metric from ahead ESPLs. Some suggestions for future work include developing a tool for measuring the ESPL maintainability developed by composition-based technologies, adding other measures to assess the maintainability of ESPL, defining other criteria and guidelines to different points in relation to maintainability. I'd like to thank everyone for the attention.